There are many possible reasons for the so-called Fermi paradox, the apparent discrepancy between the number of aliens predicted in the universe, which is lots, and the number we've actually encountered, which is none. For example, the dark forest theory suggests that all beings that are intelligent enough might also be hiding from each other, out of a kind of abundance of cosmic caution. As to how intelligent any of these potentially hidden groups could be, it depends on the scales and measures you choose to follow. As per the popular Kardashev scale, the most intelligent civilizations rule over whole galaxies, so you might think that it would be hard for them to hide anywhere, and therefore that perhaps the dark forest wouldn't apply. Going by one of the best-known alternative models, however, the physicist John Barrow's scale of micro-dimensional mastery, it might actually be that advancement comes as civilizations learn to master not the largest, but the smallest forms of matter. Instead of taking up more and more space, the cleverest aliens just become more efficient with the space they have, and the dark forest becomes more of a possibility again. One theory especially fuses this idea of aliens hiding from us through their mastery of smaller domains. The transcension hypothesis was formulated by the futurist John M. Smart. It argues that the reason we don't see aliens is because they've transcended our physical universe. They exist on another plane entirely, known as inner space. Inner space is a far more optimal and efficient dimension than our own, consisting of smaller forms of matter and energy. It's like reality 2.0 from our perspective. A defining feature of the transcension hypothesis, though, is that it also says that beings that advance enough to enter inner space have no remaining incentive to go back and contact less intelligent life. On a natural fundamental level, they would never want or need to speak to us again. There are some broader reasons why communication links would break down or never appear in this model, though. For example, one idea is that if advanced civilizations began sending messages or probes to relatively primitive life like ours from inner space, they would then risk influencing and damaging our own technological progression. Instead, it's proposed that it would be better to allow life to evolve on its own and make its own unique discoveries, to avoid the possibility of every civilization turning out the same, with the same science and achievements, and with nothing by way of diversity. The transcension hypothesis suggests, then, that we haven't met alien life yet because A, we're not intelligent enough to get to their level, and B, because transcended groups have never and will never reach out. The underlying argument of the hypothesis is always, though, that civilizations naturally progress to smaller and smaller scales of space, time, energy, and matter. And so there's a clear path toward black holes, with Smart himself referring to them as a potentially developmental destiny. Black hole life isn't only an offshoot of the transcension hypothesis or even of modern science in general. It's an idea that dates back to at least the mid-20th century, when the physicist Roger Penrose first proposed that black holes contain an enormous, nearly limitless supply of energy. We know that black holes have a region around them called the ergosphere, lying just outside the event horizon, and that any object that finds itself inside the ergosphere will be dragged through space faster than light speed. But Penrose suggested that this energy could be used via something known as the Penrose process should an object be dropped into the ergosphere but then ejected out of it after it had harvested net energy from the black hole. In this way, it's as though black holes are unrivaled energy stores, so it would make sense for the most advanced groups to live as close to them as possible. Black holes might reasonably be considered prime real estate in the universe. In fact, some physicists believe that black holes hold the potential to birth new universes entirely. Such is their immeasurable power. The suggestion here is that when a black hole forms, by a star collapsing in on itself, it could be that the energy involved rebounds outwards into what's effectively another Big Bang, producing another universe on the other side of the singularity. So the theory goes. If aliens were living in black holes then, they'd have perfectly positioned themselves along effective bridges between here and there. Again, although this time by slightly different means, they will have transcended this reality. Of course, there's some evidence to support all or parts of the hypothesis and some criticism against it. There's certainly reason to think that advanced enough beings would invest in mastering smaller dimensions rather than larger. The Serbian astronomer Milan Cirkovic is another who has taken a closer look at this. In one 2008 study, he used models to determine how aliens would operate in two situations. one where they aimed to expand outward into space, known as an Empire State model, and one where they instead optimized the space they have, in a city-state model. Surkovich found that the Empire model rarely held together all that well, mostly because it quickly became too stretched, while the city model grew stronger and stronger. Zoom out, and city-state civilizations probably would be harder to spot too, and especially if they grew intelligent enough to set up inside black holes. Consider even just humanity's ambition towards nanotechnology that works at the atomic level, and there's no doubt that such groups could be missed, easily allowing the Fermi paradox to set in. More broadly, the transcension hypothesis divides opinion. Critics say that it makes a number of assumptions in order to work. It assumes that life seemingly always develops towards the same particular goal all over the universe, that working across smaller domains is always the best strategy to reach that goal, and then that life can survive at such extremely small scales as well, with black holes being a kind of endgame. There's also that concept of inner space to wrestle with. With something so seemingly fundamental to how an advanced group would work, it might easily take such an extraordinary amount of energy that it should be something that's visible in space. But we have few candidates toward what that might be, unless the evidence of transcension is black holes themselves. So what's your verdict? Does the transcension hypothesis ring true for you? Could black holes be an integral part of that theory? Or do they remain just as mysterious as ever? For now, perhaps the main takeaway is the suggestion that to advance, we should be looking more at the very small and not the very big. Substitute the Kardashev scale for micro-dimensional mastery, and the road ahead might quickly become clearer and more achievable. If there is a universal strategy for developing civilizations, we might currently be completely misaligned with it. And were we to force ourselves back on track, it could be that our future homes will one day be found in and around the darkest and deadliest places.